Hi, my name is Linda Yao, and this is my data analysis final project for BMGT 438A. So there are similar first steps from our last data cleaning project, setting the working directory and then reading in our file from Unilever, which I have opened up right here. The two questions I'm going to answer are, if a shipment has a fixed appointment, does it have a statistically significant probability of arriving on its requested arrival date? The second question I'm going to answer is, if a shipment has a fixed appointment, does it have a statistically significant probability of having zero accessorial charges? So looking at our data, the first two columns that kind of stand out are late tolerance and on time, which will help us to solve the first question. And those two columns are the first two that I renamed here, fixed and on time. And the first thing I want to do is check correlation as well as conduct a t-test on our two columns. As you can see from the t-test, there are a few outputs. The most important one is the p-test, and our p-value is less than 2.2 times 10 to the negative 16, which is very low, especially when compared to 0.05, which is the number that usually is checked with for cutoff. This indicates that the difference between appointment times and arriving on time is significant, and that we can reject the null, and the null being that there's no relationship between fixed and on time. The bottom shows the 95% confidence interval, and the confidence interval basically tells us that 95 out of 100 times we take a group sample for comparison. The average difference between the groups is the difference between the mean x and mean y, which is about 0.59, and we can be fairly certain that the differences will be between negative 0.59 and negative 0.58. Those are very small margins. Then I did some more data cleaning with late tolerance and on time. I put it into a data frame. Here I'm going to run table customer to show you what's in our table. The table supports what we hope, which is that there's a set schedule, that when there is a set schedule, there are more shipments that are on time. And that shows up here on this bar plot. Even though the p-test shows that the difference is statistically significant, it's good practice to check the degree of freedom and the f-value. The degree of freedom can be shown from an ANOVA test and summary. The degree of freedom shows the independent pieces of information in the data. It reflects the true sample size with more data points, so it has influence over the f-value. And since we have such a large sample, there's a lower chance of error variance, and it could indicate that the data did not vary much. Since the p-value is low and the degree of freedom and f-value support it, it shows that they did a good job with delivering on time when there was a fixed arrival time, and lateness was not tolerated, with only a few cases that broke uniformity. So from our analysis, we can conclude that if the shipment has a fixed appointment, it does have statistically significant probability of arriving on its requested arrival date. Now I'm going to move on to the second question. If a shipment has a fixed appointment, does it have a statistically significant probability of having zero accessorial charges? For this question, I had to mess with the Excel sheet a bit. I created two new columns here. Here I messed around with the data that we were given. Since we didn't need to have any data, but since we only needed to know zero, whether or not it was zero for it to be statistically significant, I simplified the data set a bit by plugging in some formulas into Excel so that each one that showed zero would show zero, and anything greater than zero would show one instead. Since we only cared about having zero accessorial charges, I changed the data, so I created a new column that reflected whenever there was a zero, it'd be a zero, but whenever it was greater than zero, it'd indicate one, just to make things a bit simpler. So then I went ahead and read in those two columns here, fixed and ACC. As you can see from question 2, it sounds pretty similar to question 1, so I'm going to approach it the same way I did number 1. Looking at the available columns, I'll need accessorial costs to answer this question. And I did some data cleaning here and made the shorthand for the column name ACC. And applying the same methods from question 1, we'll look at the correlation and t-test values. The p-value is again very low. This indicates the difference is significant and we can reject the null. And the null being that there's no relationship when there is a fixed appointment and accessorial charges. Again, the confidence interval tells us that 95 out of 100 times we take a group sample for comparison. The average difference between the group is the difference between the mean of x and y, which is about 0.3, and we can be fairly certain that the difference in scores will be between negative 0.31 and negative 29, which is again a very small margin. Next, I'm going to show a box plot of our data frame, new data frame. As you can see from the table, it supports our hypothesis that when there's a set schedule, the accessorial cost will likely not be zero. And looking at our frequency plot on the right, you can see that the dark areas represent no late tolerance. It's greater than half when there's no accessorial charges and there's a fixed appointment charge. Since it's in the larger area, we can say that there is a correlation between having a fixed appointment time and having zero accessorial charges. Now I'm going to run another ANOVA test and check the values for the p-test and other values. The p-value is again very low, and this indicates that the difference is significant and we can reject the null. Therefore, we can conclude that the fixed appointment does have statistically significant probability of having zero accessorial charges. Thank you very much for watching, and I hope you enjoyed.